Hi everyone, so this is just an update video regarding the whole house dehumidifier project. So I've added this bypass valve onto it. It's a electric bypass valve, so if it frosts up then this valve can be triggered, which allows it to defrost. And also if the unit switches off, you can also equalise the pressure between the compressor and evaporator, well, condenser and evaporator, so that it can be turned on again quite quickly. So as you can see, I've got an issue with it. So when the air's quite cold, it frosts up quite easily, so this whole thing will eventually just become a big lump of frost. So if I trigger the valve just now, that's it letting much more refrigerant through, which pushes up the evaporator pressure and temperature. Now as you can see, all the frost disappears. So I'll just switch that off. It does empty the sight glass, so maybe the way I should have designed this was, instead of having the inlet pipe to this valve on the liquid, I should have maybe had it connected further up, so it's just hot gas that's going through it. I don't know if that would be a better way to do it or not. But then again, with the huge pressure drop you'd get with this being switched on, I reckon all the liquid would it might actually just bubble through anyway. I don't know. I don't really know about that. I haven't done any experiments, but I've got two of these valves anyway, so I might be able to use more of them in this system eventually, because I want to have it where I've got some sort of unit outside with a condenser evaporator in it, so that I can actually use this as an air source heat pump as well as an air conditioner, or also a dehumidifier as well. So it's like it's just recirculating the heat inside the house. I'm not really totally sure what to do with it at the moment. But the other issue this solves is to do with if the unit gets switched off. So if I switch it off, as you could hear, the compressor won't start again, but I can just use this and equalise the pressures until that stops. I may need to do a bit more until the pressures are totally equal. And that's just the valve humming. That's all that noise is. There's not really a lot I could do about that. But now it works. It's able to start up again quite quickly. Another issue I sometimes get is I hear a funny bubbling sound coming from the compressor. And it definitely sounds like it's coming from the liquid accumulator, so I think that's because all that liquid that gets jetted into the evaporator gets accumulated in the suction accumulator. But I don't think it's ever touched the compressor before, because I'm pretty sure that if liquid does get into the compressor at all, it'll just seize and it'll be destroyed instantly. And this hasn't happened yet anyway, I don't think, because the compressor's still working perfectly well. This compressor's been used in so many different projects. It's many years old and it's still working quite well. So I was thinking, you do actually get variable expansion valves, electronic expansion valves. I can see them on eBay now. There's Chinese sellers that sell them, and I think I could maybe put one on this system, but I would need to create some sort of Arduino based controller for it. And the way that would operate the system is, it would never allow it to frost up, so it would always keep the evaporator at a temperature just above the frost point. But I'd also need to be at a temperature where the evaporator, or temperature and pressure where the evaporator's been fully used, because if you don't let enough refrigerant in, the evaporator temperature, part of it gets very low and the whole thing's not being used, so you have to find a sort of a balance really. And I was also thinking maybe another type of valve you could make that's simpler to control, is just maybe have like 4 of these in a row with a capillary tube coming out of them. So it's just like you've got 4 capillary tubes that could be switched on using these, and you could switch on how many or little you want, and then you could have variable pressure control that way. Might be more reliable and simple than using an electronic sort of variable expansion valve. So to control all of that, I designed this. So this is it's just basically a relay module with an Arduino built in. So I designed this totally and bought all the parts and then assembled it here using a silk, using, you know, the solder mask and everything. Well, the surface mount stencil, and as you can see, designed by Sean Dobie. And this has a big 20 amp relay for the compressor and just 3 other relays. So one could be for that valve which opens, the other one could be for the switching on the evaporator fan, the other one could be for, I don't know, maybe some other valve, cycle reversal valve, maybe if I do go ahead and make this into an air source heat pump. But this module was actually for sale on eBay just now, and I could put the link in the description so you could buy it if you like. It's all been tested and working, so this one's for sale. I've got another prototype upstairs. I just decided to make a load of these so that if anyone else wants to get one, you can just buy it. So this is for sale on eBay just now. It isn't exactly cheap. It's £20, not including the postage. But I've tried to use quality parts as much as I can. Nichicon capacitor, if that means much. Omron relays as well. But the features it has is 4 NTC temperature sensor inputs, so you can just connect temperature sensors directly to that. So NTC 0 to 3, that's basically Arduino A0 to 3. I've named all the connections the same as it would be on an Arduino. So you've got relay pin 6, relay pin 8. So you could just type in those pin numbers into the Arduino IDE when you're making your program, and the corresponding relay will just work. I've got 2 analog inputs with 1 mega ohm pull down resistors on them as well, and they're also RC filtered. All the inputs are RC filtered as well to reduce noise a bit. PD2 to PD5, those are filtered as well. Those are actually hardware debounced. They are inputs intended for like big buttons and switches and stuff. Makes it a bit easier to connect these sorts of things. PD7's not actually got anything else connected to it. It just goes directly into the Arduino. So you can connect like a DHT humidity sensor to that. And it's also got an I2C port here. So you can connect an I2C LCD module to it, things like that, whatever you want. It's also got the ISP header on there, so you don't even have to use Arduino if you don't want to. It runs on 12 volts, and it's also got a polyfuse on it, so that if something gets shorted out, a light will come on. So it's just a little light here, so that if the 12 volt gets shorted out somehow or something goes badly wrong, you'll know about it, because that little light will come on, and it just like shows up basically warning that something's wrong. So yeah, I'm quite happy with it. It works really good, and I've got my other prototype upstairs which I'll just use. This one's for sale. It looks a lot better than my prototype. And this here is a prototype. So the symbols for the relays that I bought were actually wrong. So the coil polarity was the wrong way around on the symbol. So I actually had to put the relays on the bottom side of the board to get the correct coil polarity. Those relays are quite strange ones. They need the right polarity to switch on. But LCSC completely refunded me for that. They refunded me for the board order, they refunded me for the components that got damaged as well when I had to remove them. So that was really good of them. None of this would be possible without LCSC actually. So here we go. This is an I2C LCD module, and it's showing the state of everything. So the 4 temperature inputs, the humidity coming from this sensor here. What else have we got? It's showing the state of the those digital inputs as well. The analog input state as well. So we've got it all there, and as you can see, I've just got a load of these temperature sensors attached to it. I just got a big bag of them delivered from China. So yeah, it should be quite a good. It should be quite a good board, this, for any sort of control application really.